thermal expansion. The basic cause of thermal expansion are vibration of molecule. With increase of temperature, the vibration of molecule increase, and so the distance between molecules increase. And because of the increase of distance between the molecules, overall substance expand. So take anywhere, any two molecules, the distance will between them will decrease, right? Expansion is always थ्री डायमेंशन, क्योंकि जो लेटिस स्ट्रक्चर होता है वो हमेशा थ्री डायमेंशनल होता है, तो एक्सपेंशन इसलिए हमेशा थ्री डायमेंशनल होंगे, राइट? लेकिन हम उनको वन डायमेंशन, टू डायमेंशन और थ्री डायमेंशन में डिवाइड कर लेते हैं कब? जब अदर डायमेंशंस नेग्लिजिबल हो जाती है. लाइक इफ वी टेक अ लॉन्ग वायर, then the area become negligible in comparison to wire to V, so we take linear expansion. When we take a thin sheet, then thickness become negligible in comparison to area, then we say area expansion. And then other way, all three bodies are there, right? All three dimensions are there. For linear expansion, area expansion या volume expansion, we generally use two different formulas. One, delta L is equal to L alpha delta T, and L T is equal to L naught 1 plus alpha T, right? Here it is change in length with change in temperature, right? This is only for small change. A small change कितना? 2-3-4%, right? And this is universal. This one is universal relation. Here we are measuring length at temperature T, while L naught is length at 0 degrees C. This is length at temperature T, and this is length at 0 degree C. So while you are applying the relation, need to care that if there is a small change, then apply this, otherwise go for this. That is universal formula, right? This can be applied for any type of change, a small change, large change, whatsoever is there, right? Similarly, these formulas for area expansion become delta A is equal to A beta delta T, very much like there. Delta V is equal to V gamma delta T. These alpha, beta, gamma are coefficient of thermal expansion. Alpha is coefficient of linear thermal expansion, beta is coefficient of superficial thermal expansion, gamma is coefficient of cubical expansion, right? And they are correlated to each other, like alpha is to beta is to gamma, that is 1 is to 2 is to 3. And this is an approximation, not absolute. This is an approximation, not absolute. If the lattice structure is cubical, if the lattice structure is cubical, then it is perfect. Then the ratio will be 1 is to 2 is to 3. But if the lattice structure is not cubical, then this relation will not be exactly 1 is to 2 is to 3. और ये मैं आपको इसलिए बता रहा हूँ कॉन्सेप्ट के लिए, राइट? इट्स नॉट लाइक दैट यू स्टार्टेड थिंकिंग कि यार ये इक्वल होगा या नहीं होगा. नहीं, इफ एनी हाउ यू गेट ए क्वेश्चन, तो दिस इज फॉर दैट पर्पस. अदर देन दिस, व्हेन वी एक्सपैंड अ शीट, when we expand a sheet, then a cavity in the sheet also expand, the another cavity also expand, so when we rise the temperature, then all are increase. जितने भी मैंने डिस्टेंसेस लिए हैं सारे डिस्टेंस इंक्रीज होते हैं. लाइक ये एक कैविटी है तो ये भी एक्सपैंड होगा, ये एक कैविटी है तो ये भी एक्सपैंड होगा, ये एक कैविटी है तो ये भी एक्सपैंड होगा, ठीक है। और इनका एक्सपेंशन कैसे कैलकुलेट करेंगे, सारे आर का चेंज इसी तरह से कैलकुलेट करेंगे, राइट। चाहे वो कैविटी है चाहे वो एक्चुअल मटेरियल है, कैलकुलेट करने के लिए सारा कुछ इससे कैलकुलेट करेंगे, राइट।